Now that we've gone over the characteristics of segments within a circle, we're going to do a few examples. So in the figure to the right, the first problem's asking us about what happens when two chords intersect. And remember, with the chords intersecting, we have that the pieces of one chord, the product of the pieces of one chord equals the product of the pieces of the other chord. So let's go ahead and start with problem number 2. I'm going to have you guys go ahead and do problem number 1 on your own in a minute, but problem 2, you have RS is equal to 13. So if I highlight it, RS, that is equal to 13. Then I'm given that RQ is equal to, so a little brace here, RQ is equal to 7, which then means we know what SQ is. The difference between 13 and 7 is 6. And QU, let's switch colors now. QU is, so that's the entire segment, right, chord right there. And we have QU, so QU is equal to 3. And they're asking us what TQ is equal to. So we don't know that. So if we apply what we know, the product of the two pieces, and let's go ahead and do our work here. And as I do the work, I'll erase just so I have space. So I'll do it right above there. Number 2, problem number 2. So we have the most information on the pieces of chord RS. So 7 times 6. The pieces of RS are RQ and SQ. Their product is 7 times 6. And that is equal to 3, the piece of TU, as well as X, the piece of TU that we're trying to figure out for this problem. Now if I divide by 3, I see that I can reduce the 3 and the 6 by 2. So X equals 14 is my answer. Can I have you guys try number 1? And if you hit pause, check your answer. The answer should be 3 for number 1. We got 14 for 2. Number 3, I'm going to do together. And I am going to erase what I have here. For number 3, we have that we're given TU is equal to 10 rad 2. So TU, the entire length of the chord, is equal to 10 rad 2. We have QU is 2 rad 2. So think about it a moment. Would we know how to figure out what TQ is? So if the total is 10 rad 2, a piece of that total is 2 rad 2. I can find the difference. 10 rad 2 minus 2 rad 2 is 8 rad 2. So we subtract, remember, so adding, subtracting like radicals is like adding and subtracting like terms. 10x minus 2x is 8x. 10 rad 2 minus 2 rad 2 is 8 rad 2. And so the next piece of information is going to give us RQ is equal to 8. So RQ is equal to 8. And RS, the entire quantity, is what they want us to figure out. So the question is, what is RS equal to? So that means that we have the pieces of the blue segment of TU, of the blue chord. We don't have it of the red chord. So we're missing QS. So we'll assign a variable to it. We'll call that X. Now using that information, we have 8 times X, pieces of the pink chord, is equal to the product of the pieces of the blue chord. So 2 rad 2 times 8 rad 2. So we have here 8x equals, the 2 and the 8 are on the outside of the radical, so those two will multiply together to get 16. Rad 2 times rad 2 is just 2. Rad 4, which is 2. Divide by 8. If we, from there, simplify 8 into 16, we get 2 times 2, which is 4. Now the question was, what is not QS equal to, but what is RS equal to? And RS is the entire chord. So 8 plus 4 gives us 12. So we're going to finish off number 4, where you're given RS is equal to, so the entire chord is equal to 17. We have TQ is equal to, let me switch colors here. TQ is equal to 18. QU, so the other piece of the blue segment, QU is equal to 4. And the question is, what is RQ equal to? So RQ on the previous segment. So the tricky part of this problem is that you only have the total for RS being 17, which means we don't have either one of the pieces. So what we do is we come up with expressions. So let's say RQ is what we're trying to find, so we're going to call that X. What's an expression using 17 and X to figure out what the expression for QS would be? So we would say, let's use numbers as an example. If RQ was 2, how would we find QS? We would take 17 minus 2 to get 15. If it was 3, we'd do 17 minus 3 to get 14. So we can write an expression for QS as 17 minus X, the difference between the two. So now if we set it up as the product of, so this is number 4, if we set up the product of 4 times 18 and set it equal to X, the product of the little pieces of RS, so X times 17 minus X, we're going to get a quadratic equation. And so 4 times 18 is 72. We distribute and we see that we have something squared, which means this is quadratic. So let's go ahead and recall how we do these types of problems. We're going to isolate and set one side to 0. So we're going to add x squared to the other side, subtract 17x to the left, and then there's already a positive 72 over on the other side. The question is, if I were to factor this, is it factorable? If not, we have to use the quadratic formula. So what times what is x squared? That's x times x. What two numbers multiply to be 72 that add to be negative 17? Is that possible? And yes, it is. It's negative 9 and negative 8. So if we were to FOIL this out, we would get back to that trinomial. So now the answer I get is x equals positive 9 and x equals positive 8. So the question is, what is RQ equal to? So if I go back to the picture, RQ could either be 8 or 9. Both are positive values, so both could be a possible answer. Now, moving on to the two secants that are intersecting below, I think I'm going to go ahead and move to the harder question on 7 and have you guys try 5 and 6. 5, you should get 8.5. For 6, you should get 5. And let's talk about how you would do 7. So GF is equal to 8. And HG is equal to 10. Now switching colors on the other secant, we have DE is equal to 18. And then EF we don't know. So if you remember so this is number 7, the way that we would attack these problems is the whole entire secant segment times the external is equal to the other whole secant segment times the external. So let's use the pink one as an example. The whole entire length of the secant FH is 18, 8 plus 10. So 18 times the part on the outside, so that would be 8. And then on the blue, we have the entire FD is equal to 18 plus x times the external, which is x. So we see immediately that we have something very similar to what we had in the problem above there. 18 times 8, when I multiply it out, is 144, which is a constant. Then we have x squared plus 18x. So when we have something squared, we're going to isolate and make sure everything's to one side. So x squared plus 18 minus 144 is equal to 0. So the question is, if I were to factor this, x times x is x squared. What multiplies to be negative 144 that adds to be positive 18x? And the values are positive 24 and negative 6. So if I were to set each one of these equal to 0 to solve, I get x equals negative 24 and x equals 6. Well, if x represents the length of a segment, it's not possible for it to be negative. So my only possible answer is x equals 6 for this one, as opposed to the previous example where both were positive. So on 7, we go back to the picture. The picture we have labeled EF is x, and so we solved for x. My answer should be 6. Okay, and then as the last example, we're going to go ahead and do number 8 together. Okay, number 8, you have, and let me erase the picture. On number 8, you have DF is equal to 25. EF is equal to 4. GF is x. And HG is also x. They're both equal to each other. And so if we use the whole times the piece on the outside strategy of secants, then we have for number 8, the top secant would be the whole thing is 25 times the piece on the outside is 4. The whole thing for FH, and let me highlight this, the whole thing is x plus x, so 2x, times the piece on the outside, so 2x times x. 2x times x is x squared. So 100 equals 2x squared. And then we isolate x squared. So this one, you only have an ax squared, so you don't have to factor for this. You guys can solve it by square root method, which is isolate the x squared, and then undo the squaring by taking the square root of both sides. And although we get an answer of x equals plus or minus radical 50, we only consider the positive answer because it represents a length in this problem. We're going to go ahead and simplify 50 as 552, so we can take out a 5 and leave the 2 inside. So 5 radical 2 is the answer. Let's see, then they asked us to solve for x, which is what we solved for. So my answer to 8 is 5 rad 2.